Welcome to myprojectbazaar.com. Let me discuss about the process satellite image adaptive restoration using periodic plus smooth image decomposition and complex wavelet packet transform. Let me discuss about the process satellite image adaptive restoration using periodic plus smooth image decomposition and complex wavelet packet transform. The satellite images were first pre-processed in order to remove the noises in the image. The pre-processed image is then decomposed to periodic and smoothing component. Deconvolution process is applied to the periodic component. For deconvolution, we use complex wavelet packet transform. Then smoothing component is combined with the deconvoluted periodic component. The resulting image is the restored satellite images. Finally, performance of the process is measured by calculating the PSNR value. Here for pre-processing we are using median filter. It is often desirable to perform some kind of noise reduction on the input image of the signal. Median filtering is very widely used in digital image processing to remove the noises in the input images. Then the image is divided into periodic component and the smoothing component. This process is called as image decomposition. Pre-process decomposition can avoid some artifacts caused by the discontinuities across the frame border in the frequency domain. Edge ringing is caused by the discontinuities across the frame border in the frequency domain. Pre-process decomposition can be useful to solve the effects of the edge ringing. The periodic and the smooth components are separated by applying Fourier transform in the image. The periodic component alone is processed in the next step, and finally the smoothing component is added. The Bayesian estimator decision rule is minimizes the posterior expected values of the loss function. It maximizes the posterior expectation of the utility function. Bayesian estimate helps to find the expected loss function of the deconvolution. Deconvolution refers to removing of the blurs in the image. Deconvolution is done using complex wavelet packet transform. Noises in the images are decomposed into subbands for modeling and processing. In each subband, the deconvolution process is applied. Finally, the performance is measured by calculating the PSNR value. PSNR value is the ratio between the maximum possible power of an image and the power of the correcting noise that affects the fidelity of its representation. Now, let me see the flow of the process satellite image adaptive restoration using periodic plus smooth image decomposition and complex wavelet packet transform. Initially, the satellite images were pre-processed to remove the noises in the image. Before pre-processing, noises are added to the image. Then the images are decomposed. So for pre-processing, we are using median filter. A median filter is a non-linear digital filtering technique often used to remove the noises such noise reduction is a typical pre-processing step to improve the results of the later processing. Median filtering is widely used in digital image processing. Then decomposition is applied. The satellite image is decomposed to smooth under periodic component. P+S decomposition can avoid some artifacts caused by the discontinuous cross across the frame border in the frequency domain. Edge ringing is caused by the discontinuous across the frames border and the frequency domain. P+S decomposition can be useful to solve the effects of the edge ringing. The periodic plus and the smooth components are separated by applying Fourier transform in the image. A periodic component alone is processed in the next steps, and finally the smoothing component is added at the last. Then we are going to the Bayesian estimate. Bayesian estimator or decision rule that minimizes the posterior expected value of a loss function. Eventually, it maximizes the posterior expectation of a utility function. Bayesian estimation helps to find the expected loss of the function in the deconvolution process. Then we go to the deconvolution process. Deconvolution means removing blurs in the image. Deconvolution is done using the complex wavelet packet transform. Noises in the images are decomposed into subband thickness for modeling and pre-processing. In each subband, the deconvolution process is applied. Then finally, the deconvoluted image is combined with the smooth component to give the restored satellite images, and the performance of the process is measured by calculating the PSNR value. PSNR value is the ratio between the maximum possible power of a signal and the power of the corrected noise that affects the fidelity of its representation. Here it represents the maximum noise level and the original image level. Let me discuss about the execution of the process satellite image adaptive restoration using periodic plus smooth image decomposition and complex wavelet packet transform. If you want to run the code, select the file main.m which is located in the source code folder. Right click it and give run file. The process will start to execute. So select any one of the image which is present in the dataset. So these are the degraded satellite images, and we are going to enhance the satellite images by applying periodic plus smooth image decomposition, and then using complex wavelet packet transform. So initially the input image is this is the input image, then noise is added to the input images, then after adding noises to the input images, the input image is pre-processed using filters. Then now we are going to compare the this result and the final result using smooth and periodic component decomposition. So this is the smooth component and this is the periodic component of the image, and they are splitted. After they are splitted, we are convoluting using we are first applying Bayesian estimate in order to estimate the pixel values which in the satellite images. Now we are convoluting the images using satellite images decomposition, and then finally smooth image is combined with them, and finally we got this we got the final enhanced image. Then we are calculating the PSNR value and the SSIM value. So the PSNR value shows that the proposed algorithm occurs about 34 ranges of PSNR value. So the output image is enhanced, and the SSIM values also shows that the input and the output images were slightly different. So since it gives 9.9 and it is 1 for correct input. If the two images are same, then SSIM value comes to 1. So here it is showing 0.9% only. So the process is so the input image is slight differences. Now we are splitting the input images into the periodic and the smooth components, and then the process going is and then the deconvolution process is applied in order to remove the noises and small bursts in the satellite images, and finally we get an enhanced image, and we are measuring the performances using PSNR value and the SSIM value. Thank you.